Hello guys, welcome back to TNS Retrace, and today I'll be doing CO2 part 2 of the carbon dioxide transport. Okay, so this is the diagram that we were using before. So here we were at where carbon anhydrase converts my carbon dioxide plus water into carbonic acid, which dissociates into bicarbonate and hydrogen. Alright, so let's just let that stick there. Now what we need to know, okay, remember this is all happening in my RBCs, just that there's not enough space there. Well, there's space, but you probably wouldn't get to see the entire reaction properly. So let's just halt there and talk about the functions of your hemoglobin, right? So hemoglobin right here, a nice smiley face to the side. Okay, so four important functions we need to know: carbon dioxide transport, oxygen transport, involving the buffer system, and nitric oxide transport. Alright, and you know that is important in vasodilation. Alright, so the hydrogen that is produced, right? Again, this is happening in your RBC. The hydrogen that is produced, it is picked up by your hemoglobin chain. Right, so what I'm going to do, I'm just going to redraw the diagram here, but just to follow what I'm doing. Alright, and just put this to the side for a bit. Alright, so we're still in the capillaries. Let me just draw this section here. We're still in the capillaries. And this is your RBC. Alright, let me just draw the respiring cells, giving off the CO2 again. Alright, so the CO2 combining with water to form carbonic acid by the enzyme. This is your enzyme carbonic anhydrase. It's represented by Ca, and then it dissociates into protons, which are your hydrogen ions, and bicarbonate. Alright, so this is your RBCs, and within the RBCs you have hemoglobin. Alright, so what happens is that the hydrogen or the protons that are produced in this chemical reaction, they are picked up by your hemoglobin. You know that hydrogen, increasing hydrogen content, creates an acidic pH. So your hemoglobin picks up the hydrogens, specifically by your histidine amino acids. Alright, and then eventually you have a buildup of bicarbonate in the RBCs. So what it does, it goes out into your plasma. Goes out. Bicarbonate goes out, and then you have your chlorine ions going into your RBCs. Alright, so bicarbonate goes out, and chloride ions goes in. So you're having it there. So hydrogen ions decreases the affinity for the binding of oxygen to your hemoglobin, right? So while your hemoglobin is picking up the hydrogen, right, and that's where it plays a role in the buffer system, it is giving off your CO2, right? And it's giving off your oxygen, I'm sorry. And this is known as the Bohr effect. So that's the Bohr effect, right? So let's just go through it quickly again. Your respiring tissues, they are producing carbon dioxide, and it crosses the membrane via simple diffusion, travels from area of high concentration to an area of low concentration. So it goes from your tissues into the interstitial fluid, crosses the membrane, goes into your plasma, from the plasma into your RBCs, where CO2 combines with water and is converted to carbonic acid by your enzyme carbonic anhydrase, and the carbonic acid dissociates into the hydrogen and bicarbonate. The hydrogen is picked up by hemoglobin, right? Because if it builds up there, it's gonna eventually go into the blood and make the blood very acidic, and you don't want that because cells do not survive well, or they do not function well in acidic pH. They actually die, so you don't want that happening. So you have hemoglobin picking up your protons, which are your hydrogens, right? And while doing so, it is decreasing the affinity to bind to oxygen, so it gives off your oxygen. So it's pretty much like a cohesive, integrated mechanism. So you're giving off oxygen, which is really what you want, because your oxygen is required by your tissues for proper respiration. And the bicarbonate, which is produced, it goes out into your plasma, and while doing so, chloride enters. Okay, so that's pretty much what we'll be focusing on. In the next video, we basically will be looking at the pulmonary side, what happens there. So stay tuned, and please remember to like, comment, and share the video. Thank you so much.